When we are talking about right triangle trigonometry, we are talking about 9 letters. Sohcahtoa. Sohcahtoa. Memorize this. Sohcahtoa. We have a right triangle. There are 3 sides and 1 angle. So the angle, we call that a theta. And then we have an adjacent, opposite, and hypotenuse. We have one right triangle, right? So do you see this little box in here? This is saying that that angle is a right triangle. So what is a right triangle? A right angle. The right angle, what is the measurement? The measurement is 90 degrees. So we have a 90 degree, we have a theta, we have 3 sides. So how do you define the opposite, adjacent, and hypotenuse? The opposite and adjacent, they are always touching the right triangle. You need an opposite and adjacent, and these 2 lines or these 2 legs, they must form a 90 degree angle. How do you distinguish between the difference between opposite and adjacent? So opposite, the reason we call that opposite, because that is facing the theta. So let's say you are the theta, you are looking at B, right? So B is on your opposite side. So that's why we call that opposite. And then what about adjacent? Adjacent is touching the theta, right? So that is right next to it. It's like in your neighbor. So we call that adjacent. So a side or a leg that is touching the theta. And then opposite is on the opposite side. So if you are standing at the location of theta, you can see your opposite side. So that is called opposite. And then hypotenuse. Hypotenuse is always the leg or side that is not touching the right angle. So we have Sohcahtoa. But what is that Sohcahtoa? Sohcahtoa is SOH. So SOH stands for sine is equals to opposite divided by hypotenuse. So sine of theta, you know the theta. So sine of theta is equals to opposite over hypotenuse. Or if you don't know theta, you can still write sine theta equals to opposite over hypotenuse, and then you can solve for theta using inverse sine. And then CAH is cosine equals to adjacent over hypotenuse. And then tangent is equal to opposite over adjacent, TOA. And then once again, this Sohcahtoa works for right triangle only. If there is no right angle, no 90 degree angle in a triangle, then that is not a right triangle. If that triangle is not a right triangle, then Sohcahtoa is not applied. You have to use something else, so that we have to discuss that in another lesson. So what about the cosecant, secant, and cotangent? Well, cosecant, secant, and cotangent, what is cosecant? Cosecant is the what? The reciprocal of sine, right? So for cosecant, all you have to do is you swap the numerator and denominator of sine. For secant, you swap the numerator and denominator of cosine. For tangent, you swap the numerator and denominator of tangent. Alright? And then what else do you need to know? You need to know that we have a right triangle is 90 degree, and also other than the right triangle, we have 2 acute angle. What is acute angle? This one is acute angle, and then this one is acute angle. Acute angle is always between 0 degree and 90 degree. Between 0 degree and 90 degree. And then we have a triangle, right? How many interior angles do we have? We have 1, we have 2, we have 3, right? So the sum of the 3 interior angles, so the sum of the 3 interior angles is always equals to 180 degree, always. It doesn't matter what type of triangle you have. The sum of the 3 interior angles is equals to 180 degree. So let's do 2 simple examples for the right triangle trigonometry. So I have a right triangle right here. What I want you to do is, I want you to find the exact value of the 6 trig function, the sine, cosine, tangent, cosecant, secant, and cotangent, using this right triangle. So compare the 2 triangles you see on the screen. this one is in a different position, right? So if you want, you can quickly put that back to the one you see in the formula. So just like that. So this is your right triangle, and then this is your right angle, 90 degree, and then this is my theta. My hypotenuse is equals to 4. So this is hypotenuse equals to 4. And then on the opposite of theta, we have a 3, and then the other side we don't know, right? So this is opposite, and then this is adjacent. So what is the relationship between these three sides? You have to use Pythagorean Theorem, so which is a square plus b square equals to c square. So a you don't know, so a square plus 3 square equals to 4 square. So a square is equals to 16 minus 9, that is equals to 7. Then a is equals to, do we still use the plus or minus? In theory, yes, but we are talking about the length of a triangle. Length cannot be negative, so we use positive only. The square root of 7. So this is equals to the square root of 7. And then we follow the Sohcahtoa to find sine, cosine, tangent, and the other three trig function. And then we have sine theta. What is sine? SOH. We write out. So O is 3, hypotenuse is 4, then that is sine. And then cosine, CAH, adjacent, root 7, hypotenuse is 4. And then tangent, opposite, TOA, right? Opposite is 3. And then adjacent is square root of 7. You can take that as a final answer, but in most of the book, they don't like people having a square root in the denominator. So this one, you have to rationalize your answer. So you have to multiply the top and bottom by square root of 7. So once you do that, you have a 3 root 7 divided by 7. So that is your sine, cosine, and tangent. And then the other three, and cotangent, so we are taking the opposite, the reciprocal of Sohcahtoa. So this one is not SOH anymore. This one will be a hypotenuse divided by opposite. So that will be 4 divided by 3. And then this one will be hypotenuse divided by adjacent. So that is a 4 divided by root 7. And then you rationalize that. You have a 4 root 7 divided by 7. And then the last one, you swap the top and bottom, adjacent divided by opposite. So that is a root 7 divided by 3. So that would be the 6th trig function. Let's do one more. So the next one, let's just bring this up. We have another right triangle, and then I have two problems for you. So in problem 1 and problem 2, I have some givens. I want to find something. Okay, so let's do this one by one. So let's start with number 1. So number 1, I will just draw a triangle for each problem. So let's, number 1, then I will draw number 1. So we have B equals to 5, and then the big B equals to 20 degree. And then I need to find A, C, and big A. So the uppercase is the angle measurement, the lowercase is the length. And then I draw a right triangle. Okay, so C, do we know C? C we don't know. A we don't know either. And then B is 20 degrees, so that is 20 degrees, so that is like my theta. And then B is equals to 5, so that is the opposite. Okay, what can we do at this point? I have, this is my big A, right? So the sum of 3 interior angles, so you have 3 angles inside the right triangle, right? What is the sum of those 3 angles? The answer is 180 degree. So now I know a 90, I know a 20, I can easily find A, right? So A is you take 180 minus the right triangle minus 20 degree, so you have 70 degree. So that is the angle measurement of A. And then for the A and C, let's do C first. So we can use SOH. So we have sine of 20 degree, that is my theta. SOH, O is opposite, H is hypotenuse. And then you just need to solve for C. So C is equals to 5 divided by sine of 20 degree. Okay, one thing that you have to set in your calculator is sine of 20 degree is in degree mode. So you have to set your calculator to degree mode. How to do this depending on what calculator you are using. If you are using a graphing calculator, there is a mode key right next to the second. So if you click that mode key, you should be able to see the mode right there. One is for radian and one is for degree. If you are using a scientific calculator, the one that you cannot do graphing, there must be a mode key in somewhere. So once you press that, and then there must be an option to switch between radian and mode. So 5 divided by sine of 20 degree, once again, you need to use degree mode. So C, I have approximately equals to 14.62. So that is the length of C. And then the tangent, so we have tangent 20 degree, that is equals to what? TOA, right? So opposite divided by adjacent. So that will be 5 divided by adjacent is A, and then you solve for A. So A is equals to 5 divided by tangent of 20 degree. You use degree mode. So A is around 13.74. So that's how you find the rest of the info. And then number 2, using the same triangle, now I know 2 sides, I want to find the rest. So let's switch color for that. I'm going to draw a new triangle for myself. So this is my right triangle, 90 degree. I have A equals to 5, and then B is equals to 3, and then C we don't know. AB we don't know. I know this is a 90 degree, so this is A, and then this is B. Okay, what can we do now? Since we have 2 sides, this is number 2, we have 2 sides, we don't know the hypotenuse, then we use the Pythagorean. A square plus B square equals to C square. So C square is equals to 5 square plus 3 square. So we have 25 plus 9, that equals to 34. Then C is equals to the square root of 34. We don't do the plus or minus. We always use the plus because side, the length must be positive. This is around 5.83. Or you can approximate that later. Okay, I don't know A or B. How do I use the Sohcahtoa? You can still use it. So let me show you. So let's say we have opposite, we have adjacent. I am going to try tangent, TOA, right? So tangent of angle B is equals to TOA opposite divided by adjacent. How do you solve for B? To solve for B, you have to use inverse tangent. So we have inverse tangent. Actually, let's keep B on the left-hand side. So if we have B equals to inverse tangent of 3 over 5, what mode do you use? You use degree mode. So B is approximately equal to 31 degree, again, degree mode. So now we know B is equals to 31. Then what is A? A is the sum of all 3 angles, is 180 degree. You know a right angle, and then you minus B. So angle A is equal to 59 degree. That's how you use the right triangle trigonometry, Sohcahtoa. So in the next part, I will teach you complementary angle theorem. I see you in the next part.